Hello friends, welcome to the video lecture series of Engineering Mathematics 2. In continuation to the video lectures of reduction formulae, in this video we are going to discuss few more sums on reduction formulae, and those sums are short answer questions too. If now In equals 0 to pi by 4 tan raised to power n, then show that n multiplied by in plus 1 plus in minus 1 equals 1, and also evaluate integral 0 to pi by 4 tan raised to power 6 x. This integral is given. In is integral 0 to pi by 4 tan raised to power n, and 0 to pi by 4 tan raised to power 6 we want. Means I6 is required to be found. So how to solve this? In is given to you 0 to pi by 4 tan power n, and this tan power n I am going to split in this way: tan power n minus 2 into tan power 2. By law of indices it will be tan power n. Now in order to simplify it, tan power n minus 2 I am keeping as it is, and tan square can be written as sec square x minus 1, then multiply this outside term tan raised to power n minus 2 into sec square dx. I am going to distribute, multiply this term by 1, plus minus is minus, integral 0 to pi by 4. I am also distributing integral sign and dx also. In this way I have separated. Now if you look at the first term, then derivative of tan is present in the multiplication, and using this formula, integral of f to the power n into f dash, the integral of total function f to the power n plus 1 by n plus 1. Here the derivative of tan is present in the multiplication. In short, here f is tan and f dash is sec square. The integral of this term will be tan power n minus 2 plus 1 divided by tan power n minus 2 plus 1, and n minus 2 plus 1 is n minus 1. So this is the integral of this function. Limits 0 to pi by 4 in this way I am writing in the bracket. Now in is tan power n for these limits. So tan power n minus 2 will be what? In minus 2. Here I am writing in minus 2. Now this in minus 2 keeping as it is, so put limits here. X equal to pi by 4. This tan pi by 4 is 1 and tan 0 is 0. Therefore put x equal to pi by 4, tan pi by 4 is 1 and 1 by n minus 1 as it is, minus, if you put x equal to 0, tan 0 will be 0, minus in minus 2. Now this is reduction formula for in, and in is tan raised to power n for this integral. This is reduction formula. Reduction formula for tan raised to power n. Now in this problem, this may be asked as an MCQ. The reduction formula for tan raised to power n for the specified limits is 1 by n minus 1 minus in minus 2. This may be asked as an MCQ. Now what we have to show? We have to show this thing, n multiplied by in plus 1 plus in minus 1 equal to 1. Okay, this can be easily brought using this reduction formula. Here, if you look at this equation, it contains n minus 1 and n plus 1, and here we don't have n plus 1. What I am going to replace? I am replacing n by n minus 1 so as to get in plus 1. Replace n by n plus 1. Here replace n by n plus 1, n plus 1 minus 1 is n. Replace n by n plus 1, n plus 1 minus 2 is n minus 1. So you can shift it in the left hand side. in plus 1 plus in minus 1 is equal to 1 by n. Now have a cross multiplication. N is being shifted here. In plus 1 plus in minus 1. So this is what we have to show. This thing we have to. This is a reduction formula, and in order to get this relation, replace n by n plus 1 and we obtain this one. Now the second part of the question. Evaluate 0 to pi by 4 tan raised to 6. Tan raised to 6 means I6 we have to evaluate. What we have to find? I6 we have to find. I6 means tan raised to power 6 for this limit. I6, I4, I3, I5, I7 means in short, In you can find out from this formula. Now what I am going to do, this is our equation 1, I am calling this as equation 1 and put n is equal to 6 in equation 1. This equation 1 becomes I6 equals 1 by 6 minus 1 is 5, 6 minus 2 is 4, means I6 equals 1 by 5 minus I4. This we have obtained, and I6 is 0 to pi by 4 tan raised to power 6. Now what is required here? Here I4 is required. I am going to find out value of I4 separately. The I4 how to get? Substitute or put n equal to 4 here. If you put n equal to 4 in equation 1, then I4 equal to 1 by 4 minus 1 is 1 by 3. Put n equal to 4, I4 minus 2 is I4. Is in this way value of I4 in terms of I2 I have obtained, okay, by reduction formula. Now I2 is required. So find value of I2 again from equation 1. This equation 1 gives, put n equal to 2. If you put n equal to 2, 1 by 2 minus 1 is 1 by 1 is 1, and here I0. 2 minus 2 is 0. Now this is 1 minus I0. So you have to continue up to I0 or I1, because n is positive integer and it cannot be value of I0. How do you find value of I1 or I0? From the definition we have to find. Yes, what is the definition? In is 0 to pi by 4 tan power n. This is In. So put n equal to 0 here so as to get I0. Here you can put n equal to 0. Tan raised to power 0 is 1, and integral of 1 in the limit 0 to pi by 4 is pi by 4. This value of I0 we found, which is pi by 4. Now substitute value of I0 here, which is pi by 4. Now by back substitution, put value of I2 here. It will be 1 by 3 minus I2, 1 minus pi by 4. Now this value of I4 you substitute here. If you substitute value of I4, what I'll get? 1 by 5 minus I4. I4 is 1 by 3. Just I am multiplying this by or minus of 1 plus pi by 4. This is value of I4 which I have written in the bracket. Now try to simplify. This 1 by 5 minus 1 by 3 plus 1 minus pi by 4. Is it? Now take 15 as LCM, plus minus pi by 4 is as it is. And if I take 15 as LCM, yes, what will be there in the numerator? 3 minus 5 is minus 2. The 3 by 15 minus pi by 4 is the value of I6. And I6 is 0 to pi by 4 tan raised to power 6 is I6. In this way, value of I4 you can find out, value of I2 you can find out, value of I8 you can find out. Now, second short answer question, you may call this as MCQ also. If the reduction formula, here reduction formula we have obtained. This is the reduction formula for tan raised to n. Here reduction formula is given to you. This is reduction formula for cos raised to power n for the limit 0 to pi by 3. Reduction formula is given, and what we have to find, then the value of an integral 0 to pi by 3 cos raised to power 6 I want, and the options are also given here. Now how do you find out I6? To put n equal to 6, you will get I6. What I am doing here, n equal to 6 I am going to put. This is equation 1, and this reduction formula is given to you. Put n equal to 6. If you substitute n equal to 6 here, the I6 equals root 3 by 2 multiplied by 2 power 6 plus put n equal to 6. 6 minus 1 is 5. 5 by 6 here. And n minus 2 means 6 minus 2 is 4. So this is value of I6. Here I4 is required. So I am going to find out value of I4 separately. Put n equal to 4 in equation 1 so as to get I4. So equation 1 becomes put n equal to 4 root 3 by root 3. Here I am substituting n is equal to 6. No? If you substitute n equal to 6, then 6 multiplied by 2 raised to 6 I want. Here I have written 2. No? It should be 6. Now substitute n equal to 4. If you put n equal to 4, root 3 by 4 multiplied by 2 power 4. 4 minus 1 means 3 by 4. Put n equal to 4. 4 minus 2 is I2. Now find value of I2 separately. How do you get I2? Substitute n equal to 2 again here. Root 3 by 2 multiplied by 2 raised to power 2 plus 2 minus 1 means 1 by 2 I0. And as I said, the value of I0 and I1 from the defined function you try to find out. The value of I0 I am going to find. The I0 equals, put n equal to 0, cos raised to power 0 is 1. Cos power 0 is 1, I am writing directly. Because integral of 1 is x, or lower limit 0 and upper limit pi by 3 is pi by 3. So in this way, value of I0 we have obtained. Put value of I0 here. Root 3 by 2 multiplied by 2 square. Or you can write here 2 to the power 3 also. Plus 1 by 2. And the value of I0 is pi by 3. Now put value of I2 here in back substitution. Root 3. This is 2 square, 2 raised to power 4, 3 by 4 and I2. What is value of I2? I2 is root 3 by 2 raised to power 3. This is 2 raised to power 3 plus pi by 2 into 3. Or 6 you can write, I am writing here 2 into 3. Now, put value of I4 here. Now, this value of I4 I am substituting. The value of I4 is this one. Value of I4 I am going to write in this way, 2 power 6. Then 3 root 3. 2 square into this is 2 power 5. Plus 3 pi 2 power 3, 2 into 3, 2 power 2 means 2 power 3 multiplied by 3. So this value of I4 I am substituting here. Then multiply each term by 5 by 6. This I am getting. Then root 3 by 2 raised to 6 is common. Root 3 by 2 raised to 6 I have taken common. Then 1 by 6, 5 by 6 and 5 will remain. This 2 raised to power 3 multiplied by 3. It is 8, 24. 24 multiplied by 6 is 144. Now, root 3 by 2 power 6 is 64. 2 power 6 is 64. And this is, if 6 is LCM, Then 1 plus 5, 6, 6 plus 30 is 36, 36 by 6 is 6 I am writing here. And here 3 5s are 15, and this is divided by 3 is 48, is it? Now this equals, here 3 2s are 6, I am writing 3 root 3, this is 32 plus 5 pi by 48. So this is value of I6 here. So is there the option, see 1, 2, 3, 4, 3 root 3 by 32, 5 pi by 48. Okay, this is the correct option. So in this way, the value of I6 we have obtained using this formula. Now next problem, if In is 0 to pi by 4 tan power n, and In is also given, means reduction formula of this is given. This we have already proved, but now this in this problem this is given. Then I4 is equal to what? So put n equal to 4 here. If you put n equal to 4, I4, 4 minus 1 is 3, 4 minus 2 is 2. Find value of I2 separately. Put n equal to 2, use value of I2 I'll get 2 minus 1 is 1, I0. And find value of I0 separately. Previously we have done it. 0 to pi by 4. From definition we have to find out value of I4 and I1 and I0. So put n equal to 0, tan raised to 0 is 1. And integral of 1 in the limit 0 to pi by 4 is pi by 4. The put value of pi by 4 means I0 here. The 1 minus pi by 4 is the value of I2. Put value of I2 here again. 1 by 3 minus 1 minus pi by 4 is 1 by 3 minus 1 plus pi by 4. Next step here I am writing. If you take LCM as 3 first two terms, then minus 3 plus 1 is minus 2 by 3 plus pi by 4. Minus 2 by 3 plus pi by 4, this is the correct answer. Now the same problem again. If In is this one, then reduction formula for In is given to you. This is reduction formula for 0 to pi by 4 cos to the power 2n is given to you. The value of I2 is asked you. So put n equal to 2 in equation 1. If you put n equal to 2 in equation 1, equation 1 implies I2 equals minus 1 by n. N is 2. 2 power n plus 1, because n is equal to 2 I am putting. 2n minus 1 by 2n. N is 2. I 2 minus 1. Therefore, this 1 by 2 power 3, 2 is 2 power 4. You can write 16 also directly. 4 minus 1 is 3. 3 by 4. And this is I1. So find value of I1 separately. How do you get a value of I1? You can find out value of I1 from here also. If you put n equal to 1, then 0 to pi by 4 cos raised to power 2, and cos square x can be written as 1 minus cos 2x by 2. In that way you can find out. Or you can again use formula 1 to find out the value of I1. Yes, I am putting here n is equal to 1 so as to get I1 in equation 1. I1 equals, put n equal to 1. I am putting n equal to 1. I am putting n equal to 1 here. 2n minus 1 by 2n, n is 1. And put n equal to 1. 1 minus 1 is 0. Now minus 1 by 2 square. You can write 4 also. 2 square. Plus 2 minus 1 is 1, 1 by 2, I0. And the value of I0 is what? Value of I0 writing directly. I0 equals 0 to pi by 4. Cos raised to power 0 is 1. Means integral of 1 in the limit 0 to pi by 4 is pi by 4. So put value of I0 here, minus 1 by 4 plus 1 by 2. And value of I0 is pi by 4. Put value of I1 here again, minus 1 by 2 raised to power 4, 3 by 4, and I1 is minus 1 by 4 plus pi by 8. This is pi by 8. Now, minus 1 by 16 plus minus minus 3 by 16 plus 3 pi by 32. This multiplied by this. Now, 16 is LCM here in the first two terms. Minus 1 minus 3 is minus 4, minus 4 by 16 is minus 1 by 4, 3 pi by 32. This is the value of I2. And I2 is what? I2 is the value of I2 means value of I2 we found. The I2 means integral 0 to pi by 4. Put n equal to 2 means we found value of I2 means cos raised to power 4. Means value of this integral we have evaluated. This is I2. Value of I2 or value of integral cos raised to power 4 for these limits we have evaluated. Now what is the correct answer out of it? 3 pi by 2 plus 1 by 4 is the correct answer. Now here in this option plus is there, but we have here minus 1 by 4. This is minus and minus, it will be minus 1. Minus 1 by 4 plus 3 pi by 2. And you can check it once again to get the value as the correct answer. Now, the next problem. If n equals 0 to pi by 4 sine 2n minus 1x by sine x dx, reduction formula is given to you. This is the reduction formula of iron. Then the value of I3 is required to be found. So how to get value of I3? This is our equation 1 is given reduction formula. Put n is equal to 3 in equation 1. And equation 1 employs put n equal to, what to do? Put n equal to, I want I3. See, here I want I3. But reduction formula in terms of n plus 1 is given. Means we have to substitute n is equal to 2. Put n is equal to 2 here. Okay. Put n is equal to 2. Put n is equal to 2 so as to get I3, because the reduction formula of in plus 1 is given to you. Put n is equal to 2 so as to get I3, and I3 is required to be found. Then if you put n equal to 2, what will happen? I3 equals, I am putting n equal to 2. I am putting n equal to 2 in pi by 2 plus I2. Now, sine, this 2 gets cancelled, sine pi is 0, 0 plus I2. This value of I3 is I2 here. Now find value of I2 separately. I2 how to get? This is the reduction formula for in plus 1. So put n is equal to 1 in equation 1 so as to get I2. Means I2 is equal to 1 plus 1 is 2. 1 by 1 sine n pi by 2 is 1 pi by 2. I am putting n equal to 1 plus I1, and this equals sine pi by 2 is 1 plus I1, and find value of I1 from this equation. Find value of I1. If I put n is equal to 1 here, but you get 0 to pi by 4 sine 2 minus n is equal to 1. 2 minus 1 is 1. Sine x I am writing directly, and sine x in the denominator as it is. The sine x has, both the sine x have 1. 1 is remaining, and integral of 1 for the limit 0 to pi by 4 is pi by 4. This value of I1 is pi by 4. I am putting here 1 plus pi by 4 is the value of I2, and I am putting value of I2 here again 1 plus pi by 4. So this is value of I3. This is value of I3 and I3 is 1 plus pi by 4. This is the correct answer. We stop here. Thank you very much.